Using scalar product, dot product, show that ABC is a right angle. So if ABC is a right angle, ABC, well, that means the BA dot BC must be 0, because if they're perpendicular, the dot product is 0. So let's just find BA dot BC. BA is the A minus B basically, so the coordinates of A, which is this guy here, minus the coordinates of B. And BC is C minus B. So the coordinates of A would be this, which is 205. Notice that there is no J component, so the Y component or the J component is 0. So this is 205, this is 323, and the C is 111. Okay, so we subtract, we get minus 1, minus 2, 2, subtract, we get minus 2, minus 1, minus 2. The dot product means we add the product of each corresponding component. So for the x component, minus 1 times minus 2, minus 2 times minus 1, 2 times minus 2, we multiply everything and then we add everything, and we should get 0. Since the dot product is 0, draw a conclusion. Therefore, the angle ABC is 90 degrees. Show that isosceles. Isosceles means same length. So we're gonna need the length BA and BC. This is the factor BA. The length is therefore the magnitude, so square root of the sum of the square of each component. So minus 1, minus 2, minus and 2, all squared, 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 plus take the square root, we get 3. And same thing for the BC. The sum of square of each component, take the square root, you get 3. Same length, so ABC is also isosceles. Okay, so ABC is an isosceles right angle triangle. Use exact length of the perpendicular from O to the line through B and C. So we have this point B and point C. Previously we know this is the factor BC. To find the line through B and C, we can use point B or point C for the point factor here, and the direction BC or CB. So here we are using the point C because it's simple here, 111, and we use the direction BC. Actually we are using CB, so that's 212. Okay, so here we are using point C and direction CB. Okay, now this is the line. Just make a little diagram. This is the line equation. This is the origin O. We need to find this distance from O to, let's say, P is the foot of perpendicular here. So we don't know the coordinates of P. Let's call it X, Y, Z. So since OP is perpendicular to the line, we can use the factor OP dot the line direction equals 0 because they are perpendicular. So the factor OP is P minus O, X minus 0, Y minus 0, Z minus 0. So just X, Y, Z. This is the factor OP. And the line direction is from this. This is the line direction. Dot product. So we multiply x times 2, 2x, and so on. So we have 2x plus y plus 2 plus 2z. Actually, there is a 2 here. 2z. Now, here we have an equation in 3 unknowns, 3 variables. There's nothing we can do. So now we're going to use the fact that this p is on this line, which means it satisfies the line equation, which means we can replace the x with 1 plus 2 lambda, we can replace the y with 1 plus lambda, and the z with 1 plus 2 lambda. So that's what we do here. We express x, y, z in terms of lambda, and then we open up the brackets, and then we solve for lambda. So lambda is minus 5 over 9. Now that we have lambda, we can find the point P. So we replace the parameter lambda with minus 5 over 9, and then use a calculator. 1 minus 5 over 9 times 2, and so on. We get this point P. To find the length or the magnitude, we use the square root of the sum of square. So yeah, you just use a calculator, we get the length of the perpendicular, which is the final answer. All right, I'll see you again next time.